So now let's consider a confidence interval computation for two independent means. Okay, so what are we going to be looking at here? Kids and leisure. So young children require a lot of time, and this time commitment cuts into a parent's leisure time. So a sociologist wanted to estimate the difference in the amount of daily leisure time in hours of adults who do not have children under the age of 18 years and adults who do have children under the age of 18 years. Okay, so we're just going to be looking at the amount of leisure time for these two separate groups, adults with children, young children, and adults without young children. So a random sample of 40 adults with no children under the age of 18 resulted in a mean daily leisure time of 5.62 hours with a standard deviation of 2.43 hours. Okay, so if you have no children at home, or under the age of 18 at least, you're going to have yourself 5.62 hours of leisure on average. Now, a random sample of 40 adults with children under the age of 18 years, so these are the adults with children, resulted in a mean daily leisure time of 4.1 hours. Okay, so we've got a difference, clear difference in the amount of leisure time. And there's a standard deviation of 1.82 hours for that sample. So the difference I'm talking about, right, you just look at these two numbers, the 5.62 and the 4.1. And our goal really is to determine a confidence interval for that difference. So is there a 90%, can we find a 90% confidence interval for that mean difference? And so we can say with 90% confidence that the difference between the amount of leisure hours of the two groups is in that range. Okay, so our point estimate is going to just be the difference between the two sample values, and our confidence interval will be based on the margin of error on either side of that point estimate. So in fact, let's write down that point estimate. So the point estimate is the 5.62 minus 4.10. Okay, and that's equal to 1.52. So we're observing about a 1.5 hour difference between the two groups. Right? And let's write this down. This is x1 bar, x1 being group with no children, and the group with two children, with some children, is x2 bar. Okay, so that difference is 1.52. That's our point estimate. After computing our point estimate, for doing a confidence interval, we want to compute the margin of error according to the formula that we have, t sub alpha over 2 times this square root of the s1 squared over n1 plus s2 squared over n2. I believe we don't have to check any normality conditions because the sample sizes are large enough. But we do use the t-distribution here. Okay, so we want to plug our numbers into that formula. So for the first number here, the t sub alpha over 2, let's note that alpha equals 0.1. So alpha over 2 equals 0.05. And so we want the t-score that results in alpha over 2 area in the right tail. So we'll go into Excel to find that. Okay, so we just do t inverse. And because this returns the left tail, we're actually going to do 1 minus alpha over 2 for our probability. 1 minus 0.05. And our degrees of freedom have to be the minimum of the two. So I think we're going to have to go back and look at the numbers. The first sample was 40 adults, and the second sample was also 40 adults. So the same sample sizes here. That's good. And so we can use degrees of freedom equal 39, one less than the sample size. And this gives us a t-value of 1.685. Rounding that to 3 decimal places. Okay, so that gives us the t-value. Everything else is given to us in the problem description. So the S1 is the standard deviation for the first sample. That's the 2.43. That's squared divided by the sample size N1, 40. The standard deviation for the second sample is 1.82. That's squared, and we divide by 40. All right, so all we have to do now is plug in these numbers into an Excel spreadsheet calculator to calculate the margin of error. So let's just do that. We have this over here somewhere. We have the 1.685. It's telling us to times that by a square root. And the square root of what? So we take 2.43 squared, the second power, and divide that by 40. And we add to that 1.82 squared divided by 40 as well. Okay, so I believe I copied that formula correctly, and this gives us a margin of error of 0.808. Let's just round that to 0.81. Okay, so margin of error is 0.81, and so let's now do our confidence interval. It's the point estimate, which is the estimate for D. X1 bar minus X2 bar is D bar, plus or minus the margin of error. So this equals 1.52 plus or minus the margin of error of 0.81, and that equals, let's just add that 0.81 and subtract it. So 1.52 minus 0.81 is 0.71. And 1.52 plus 0.81 is 2.33. So this is our 90% confidence interval. For the difference between the average daily leisure time of the two groups in question, those with young children living with them and those without. So we've computed a 90% confidence interval for that difference. So just to be clear on what that means, we can assert with 90% confidence that parents without young children in the house, or people without young children in the house, have on average between 0.71 and 2.33 more leisure hours per day than those with young children in the house.